Hello students, my name is Manoj Kumar. Now I am uploading next video. In this video, we will start new topic Venn diagram. Before start this topic, we will complete our 3 questions of the previous exercise. You can see question number 7th, 8th and 9th. See the second part. In the second part you can see on the both side there are closed brackets. So its answer is in interval form you can write down x belongs to all real numbers and your value of x, and you will use these signs less than or equals to 6. So this is the answer of a second part. Now see the third part. In third part, in left hand side you can see open bracket and right hand side you can see closed bracket. So its answer is in set builder form is x belongs to all real numbers and the value of x, see left hand side 6, so here we will use this sign, and right hand side 12 is there, so we will use this inequality. So this is the correct answer of the third part. The eighth question. In eighth question, what universal set would you propose for the each of the following? The set of the right triangles and the set of the isosceles. See, the set of all possible triangles is the universal set. All possible triangles is the answer of this one for both cases 1 and 2. Now see the ninth question. In ninth question, they have given 3 set A, B and C. Which of the following may be considered the universal set of set ABC? Its answer is the third part because it contains set A, third part contains set A and set B and C. So its answer is this one. Now I am going to start Venn diagram. What is Venn diagram? Venn diagram, there is a relation between sets can be represented by means of the diagram which are known as diagram. In other words, we can say when sets are represented with the help of diagrams that are known as Venn diagram. And here you can see in these diagrams consist of rectangle and a closed bracket. Closed curve, usually circles. The universal set is always represented by rectangle and its subsets by circle. Please note down, only we will use 2 types of the diagram. First is rectangle and second is a circle. Rectangle is used only for universal set and circle is used for its circle. See the first example. Here you can see universal set consists first 10 natural number and set A having element 2, 4, 6, 8 and 10. Now see its diagram. Its diagram is this one. You can see all the numbers of the universal sets are here inside the rectangle 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. But inside the circle only 2, 4, 6, 8 and 10. Now see one more example. Example number second. Here universal set is again first natural number, set of natural number and set A having 2, 4, 6, 8 and 10 and set B having 4 and 6. Here you can see B is also subset of A. So all the elements 1 to 10 lie inside the rectangle, and the element 2, the numbers 2, 4, 6, 8 and 10 lie inside A, and only two numbers here 4 and 6 which are lie inside the B. See the first operation, that is known as union of a set. And what is the union of sets? You can see here, let A and B are two sets. The union of A and B is the set which consists all the elements of A and all the element of B. The common elements are taken only once, and union is represented by this symbol, and union of A and B is represented by this. Now see the example 12. Here they have given two sets, set A and set B. Set A consists 2, 4, 6, 8 and set B consists 6, 8, 10 and 12. Then find the union of A and B. You can see very clearly. It's a very simple question. The union of A and B is 2, 4, 6, 8, 10 and 12. We can write down all the elements of A and B, but the common element taken by only one time. See one more example. Here set A consists all the vowel number A, E, I, O, U, and set B contain A, I, U. Then show that A union B is equals to A. Firstly, we will find his left hand side, the union of A and B. The union of A and B is here A, E, I, O, U. Why? Because all the elements of B lies in A, and which is equals to A. See the Venn diagram for A union B. This is the Venn diagram for A union B. The union of A and B is the set C, which consists all the elements which are either in A or B. So in symbols we can write down A union B is this one, and this shaded portion is known as A union B. These are some properties first which are used, properties of the operations of a union. The first one is commutative law, second one is associative law, and third one is law of identity and idempotent law, and this is known as law of universal. These are important properties of the operations of a union, and we will use in exercise 1.4. Now we will start second operation, that is known as intersection of sets, and the symbol of intersection is converse of union. You can see here, and see the definition. The intersection of A and B is the set of all the elements which are common to both A and B. Please remember, note down this line, all the elements which are common with both A and B, and the symbol of intersection is here used by this sign. In simple word, we will say the intersection of two sets, we will take the common element from both set A as well as set B. That is known as intersection of A and B. See the Venn diagram for intersection of set A and B. This common portion, you can see is known as A intersection B. And read this definition: the intersection of set A and B is the set of all the elements which belongs to both A and B. You can see when there is nothing common between A and B, this type of the sets are known as a disjoint set. See the Venn diagram of a disjoint set. There is nothing common, and we can write down A intersection B equals to phi when they are disjoint. See some properties of operations of an intersection. First is here commutative law, second is associative law, law of phi and union, then idempotent law and distributive law. See the next topic, that is difference of sets. The difference of set A and B in order is the set of the element which belongs to A, not B, and symbolically we can write down A minus B. See example number 18. Here the set A having 1, 2, 3, 4, 5 and 6 and set B having 2, 4, 6, 8. Then we will find here the difference of from A to B and the difference from B to A. See the answer of A to B. Its answer is 1, 3 and 5. We will take only elements of A, not of B in A minus B. But in B minus A, we will take only the element of B, not A. See its result. And remember, A minus B is not equals to B minus A. It is important result. Students, in exercise 1.4, totally this exercise based upon these topics. First is union of the sets, and we know that what is the union of the sets. The union of a set A and B is the set which consists of all the elements of A and all the elements of B, and the common elements being taken by ones. And second topic that we will use in 1.4, that is the intersection of sets. So in intersection of the set A and B is the set of all the elements which are common to both A and B. It means we will use only common elements of A and B. And third one is difference of the set. The difference of the set A and B in order is the set of the element which belongs to A but not belongs to B, and it is represented by A minus B. And remember, which A minus B is not equals to B minus A. So you will use these results and you will try yourself exercise 1.4. It is very easy exercise. I hope you can do it. So after finish this, we will start new topic, that is the complement of the sets. See, complement of the sets. Now I am going to explain what is the complement of the set. See the definition of it. Let U be the universal set A. Let U be the universe. See the definition of a complement of the set. Let U be the universal set and A is a subset of a U. Then the complement of A is the set of all the element of the U which are not the element of the A. Symbolically, we can write down it A dash to denote the complement of A with respect to U. You can see here we can write down like this: A complement is equals to x belongs to U, and but x is not equals to not belongs to A. So obviously we will take complement means which are not the part of a set A, and but they are the elements of a universal set. So remember, see the example. In this example, let U be the universal set and it contains first 10 natural numbers. See the example 20. In this example, U contain first 10 natural numbers and A contain only 1, 3, 5, 7 and 9. So what is the complement of A? So its answer is very simple, which are not the part of A, but they are the elements of a universal set. See, so what are left? 2, 4, 6 and 8. So it is, so A dash having these elements and it is known as the complement of set A. Now I am going to explain same topic with the help of a Venn diagram. You can see U is universal set and A is the subset of it, and A dash is the complement of a set A. Now you can see some properties of the complement sets. First is complements law, very important. A union its complement is always equals to universal set. We can say the sum of A and its complement always equals to universal. And second, the intersection of A and its complement is always equals to phi. See De Morgan law. In De Morgan law, you can see the complement of A union B is equals to the intersection of A complement and B complement. And see the second part, the complement of the intersection of A and B is equals to the union of A complement and B complement, and double complements is always equals to same. And the law of the empty set, phi is equals to union, then complement is also phi. Students, I am going to start exercise 1.5, and in this exercise we will use only this concept, complement of a set. So we know that what is the complement of a set. Let U be the universal set and A be a subset of U, then the complement A is the set of all the element of U which are not the element of A. I hope you understand what is the meaning of a complement of set. See the first question. In first question, what they have given. See the first question. In first question, let U be a universal set and its elements are first 9 natural number, then A is a set which contain only first 4 natural number, and set B, it contains 2, 4, 6 and 8, and C contains 3, 4, 5 and 6. See the first question. We have to find the complement of A, and you can see the solution of it. Complement of A is equals to universal minus A, and you will take only those elements which are the part of universal but which are not a part of A. So we will eliminate 1, 2, 3 and 4, and rest of the elements of the U are the elements of this set, that is known as the complement of A. And in same way you can find its B part. You will take only that elements which are the elements of U but that is not a element of B, and its answer is 1 3 5 7 9. See the third part. In third part we have to find the complement of A union B. So here firstly you will find A union B, sorry, A union C. And what are the A union C? You will write down all the elements of A and C, but common element you will write down only one time. So 1 2 3 4 5 and 6. So firstly what you will find A union C, and it contains 1 2 3 4 5 and 6. So you will find its complements. So remaining elements are its 7 8 and 9. This is your answer of this, the complement of A union C. In same way you will find its fourth, fifth and sixth part. See second question. In second question they have given, if U be the universal set and it contains A, B, C, D, E, F, G, H, find the complement of the following set. It is same as a question number first, and your set A is given, B is given, C is given and D is given. The complement of A here D, E, F, G, H, and the complement of B are here A, B, C, H, and the complement of C are here B, D, F, H, and the complement of D are here B, C, D, and E. And in same way you will solve question number third. In question number third, taking the set of the natural number as a universal set. So write down the complement of the following set. See the first part. They have given a set in set builder form, and try to understand it. X is a set of all the even natural number. So its answer is here downside. Complement of this set is X is the odd natural number. Suppose A is your set of even natural number, so its complement is odd natural number. See the second part. X is the odd natural number, so its answer is even natural number. See the third one. X is a positive multiple of 3, so its complement is X is not a multiple of 3. X is not a multiple of 3. See the fourth part. X is a prime number, so its complement X is not a prime number. See fourth question. In this question what is given? A universal set which contain first 9 element, and set A contain 2, 4, 6 and 8, and B contain 2, 3, 5, 7. So here we will verify this result. The complement of A union B is equals to the intersection of A complement and B. See its solution. In first step you will find here A union B, and the A union B is 2, 3, 4, 5, 6, 7, 8, and then you will find the intersection of complement of A union B, and that is 1 and 9. And then you will find the complement of A, which is equals to 1, 3, 5, 7 and 9, and after that you will find complement of B, which is equals to 1, 4, 6, 8 and 9. And after getting this, you will find its right hand side, and your right hand side is intersection of A complement and B complement, and that is equals to 1 and 9, and which is also equals to its left hand side, that is equals to the complement of A union B. This we have to prove.